Okay, so we are here doing area of a triangle. And we're really just building on what we did yesterday with area of a parallelogram. So what I've given you is I've given you three triangles, and I'd like you to try to think about what the area of each triangle has to be. And you should feel free to do this the old-fashioned way by just like counting the boxes, figuring it out. Pause the video, think about it for a while, and then let me know what you think. Okay. So by now you've unpaused and you have a hypothesis, okay? I will point out just one thing, that this one contains one full box, and then one almost full with a little partial, and then one mostly full with a little partial. So I'm really comfortable having our estimate of this be 3 square units. And this guy has, again, some partials, but we got 1, 2, 3, maybe these are 4 together, 5, maybe these are 6 together. So we're somewhere around 6 over here. And then here, we have 1, 2, 3, 4, 5, maybe 6, maybe 7 over here. So we've got something around 6 square units, 7 square units, and 3 square units, okay? Just using the box counting method. And I want to build on what we did yesterday by taking a look at a quick parallelogram, okay? Every single triangle in the universe can actually be transformed, just like we magically transformed the parallelogram into a rectangle yesterday. And we came up with a rule for parallelograms: base times height, right? This whole orange thing is base times this height, right? Which we deduced yesterday. It happens to be that because the triangle has a relationship to the parallelogram, we can use the same rule. So my question is, what part of the parallelogram it is? So see this red piece of the parallelogram? I just cut the parallelogram in, what's that word? Well, if I take this parallelogram and I flip it up, I flip this triangle up. So, and I put them right on top of each other, they fully cover, because this triangle was in fact half of a parallelogram. That's the big idea right here, that it is half of the parallelogram, okay? Now, that's really important for us because we already know that we can take a parallelogram and we can rearrange it, okay? So this orange triangle, imagine we're trying to find its area. I'm actually going to move it to the side because I have it in pieces here, okay? And what I did is I took this half of the parallelogram and I decomposed it. Okay, I cut it into 2 pieces. That's what decompose means. And behold, we have a rectangle. And this rectangle has the same height of the parallelogram. It has the same base of the parallelogram. But is it all of the area? No, this orange triangle is half the area of the parallelogram. So the rule for any area is going to be that the area of a triangle is going to be the base times the height divided by 2. Since base times height gives you area of a parallelogram, which we already know, and the 2 tells us that the triangle is only half of it. So let's go back to that previous slide and let's use our friend the highlighter to figure out what's going on here. Well, we have a base over here. We're going to talk a bit about what's a base and what's a height in just a second. We have a base over here of 4, okay? We have a height over here of 3. Okay. We have a base over here of 1, 2, 3, 4, 5, 6, 7, 8, and a height of 2. Base of 8, height of 2. And once, by the way, you divide it into these pieces, you can really see the half. If we, for example, switched highlighter colors for a second, we would see that this triangle that's been sort of cut off is half of this rectangle, right? And this part of the triangle is half of this rectangle. So we can really see where that half of the parallelogram thing comes in if we've got it on a grid like this. Okay, so back to our previous highlighter, and I'm gonna have the numbers on the next slide. There's a slide I have that you have. And this is super helpful because it's a right triangle. It's actually the easiest one we're gonna do because both the base and the height are sides. This is gonna have a base of 2 and a height of 3, or if you prefer to say it the other way, a base of 3 and a height of 2. Okay? So I drew those over here. So let's use these rules to find the area of these triangles. The area of a triangle is base times height. That's the area of the related parallelogram divided by 2, since the triangle is half the parallelogram. Okay? So over here, we have 4 times 3 divided by 2, which is 12 divided by 2, which is 6 square units. This one's hard to write on, but easier to manipulate, which is why we're using it. It looks a little different than what we're used to, I know. This one has a base of 8 and a height of 2. So we've got 8 times 2 divided by 2. And you guys know that 2 over 2 equals 1. These factors actually cancel out, and we're left with 8 square units. That's quite close to our estimate, or my initial estimate. And then here we have 2 times 3, again, all divided by 2. So that's 6 over 2, or 3 square units. Okay, so now we're going to practice some more. So I've given you 3 examples here, and 2 are relatively straightforward and one's a lot trickier. Most of us are going to see are going to be like 14 and 15. 16's super tricky because it's an obtuse triangle. Okay, so 14 is a nice, normal, acute triangle, and it has an height of 4. Its base is actually 7, okay? Its base is actually 7. Most of the ones that you're going to see are going to be a little bit more straightforward than this. But we got a base of 7 and a height of 4. So we are going to do base times height divided by 2. So then we can do 7 times 4 divided by 2. We can also write it like this. The order of operations will be the same. And that's 28 divided by 2, which is 14, and the correct units are square meters. That's really large. A square meter is quite large. Okay. These are also large. They're in yards. Now, this is a right triangle. We're going to talk more about those. And remember that the base and the height have to meet at the right angle. So even though the 7.5 sort of looks like it's on the bottom, we don't have the matching height that goes with the that base. Okay, we're going to talk about this more on the other screen. Right here we have a base, but we need our base here to hit the height at a right angle. So when we have no choice, we don't have enough information, we don't have enough skills yet, although we're going to learn some more things that we can do with this one day. And by one day, I mean in 9th grade. And we have to choose the ones that we can work with. Okay? So just like the base here was 7 and the height here was 4, the base here is 6, the height is 4.5. And so we can just do, I am actually thinking I could probably type and that will be faster for you fine folks. 6 times 4.5 divided by, I don't have a division symbol right this second, divided by 2. This is what we'll do. So, the easiest thing to me in my mind to do is what I would do is I would do, well, what's 6 divided by 2? And then multiply that by 4.5. You could do it the other way. You could do 6 times 4.5. 6 times 4 is 24, right? 6 times 0.5 is 3, so 6 times 4.5 is 27. And that's divided by 2. So our final answer is actually going to be a decimal. It's going to be 13.5, and that's square yards. Okay, so this last one here is quite tricky. Basically, I'm going to come back to this last one here at the very end. Well, it'll be like our bonus video, okay, for those of us who are up for the seriously spicy. Okay, so let's go through some vocab, okay? And let's just understand what we just did there. The base is always which part of the triangle? The base always has to be a side of the triangle, okay? One of the sides of the triangle is the base, okay? Now the height, we saw a triangle where the height was a side of the triangle. We saw that on that very first slide. Figure C was a right triangle, so the height was a side. But for most triangles, the height, like for example in this one, this is the height. It meets the base at a right angle. But it isn't a side of the triangle, right? So for acute triangles, it's going to be somewhere inside. And for our spicy bonus video, I'll talk about obtuse triangles. Now every triangle has 3 sides. So every triangle has 3 potential bases, right? I could use this side as the base. I could use this side as the base. I could use this side as the base. I just have to make sure the height matches. So what does the height have to do? We're going to fill it in right here. The height has to, let's see if I can change the text. The height has to go from one side of the, right, from one base, one side of the triangle to where? Where can it go? It actually has to go to the vertex, okay? That's an important restriction, okay? I can't just start drawing random lines. It has to go at a 90-degree angle from one side to the opposite vertex, okay? So that is a really important point. So we have to be able to find our base, find our height, ignore the extraneous information, and we'll be okay. So if we have 3 potential bases, we actually have 3 potential heights. Every triangle has a height and a base that goes together. And then those of us who are going to get into the spicy stuff, well, we will get into the spicy stuff soon in the bonus video.